This presentation is in the continuation of the previous presentation where we have discussed how to create a single linked list. So let's get started. In the previous presentation, we have already seen how to create a single linked list which consists of two nodes. Now in this presentation, we will see how to add the third node to the list. Adding the third node of the list is not that easy. We will see in this lecture how to add this node to this list. We have seen this program already, which helps us in creating a single linked list containing only two nodes. Here you can see this list contains two nodes, and here this is the first node and this is the second node of the list. And you can see the head pointer is pointing to the first node of the list and current pointer is pointing to the second node of the list. And head link equals to current means that this head link, that is the link part of the first node, should contain the address of the second node, because current contains this address 2000. So you're basically using this pointer for accessing the address of the second node, and you're simply putting that address within this link part of the first node. Now, here I would like to discuss two different methods for adding the third node to this list. And here is method number 1. In method 1, we will simply create another pointer which will point to the third node of the list. And here is how you're doing this. You're calling the malloc function, of course, for allocating memory to the node. And you're storing the address of the node within this current2 pointer, this pointer you have created, right? Now with the help of this current2 pointer, you're trying to access the data part as well as the link part. And finally, using this current pointer, we are trying to access the link part of the second node, and we will put the address of the third node to the link part of the second node. That is what we are doing here. Let's see how to represent this pictorially. This is how it looks like. The single linked list has been created, no doubt about this. Here we have the head pointer which is pointing to the first node, current pointer which is pointing to the second node, and current2 pointer which is pointing to the third node. By using this line, we are actually updating the link part of the second node. This is method number 1. Seems quite easy, right? But there is a problem with this method. Actually, we are unnecessarily using this pointer, that is current2. Imagine that you have to create a single linked list which contains 20 nodes. Now think about it. You have to create 20 different pointers for this. Isn't that unnecessary wastage of memory? So here I'm going to discuss method number 2, which is much better than the method number 1. So let's see what is method number 2. I would like to ask one question before moving on to method number 2. What does head link give? Very simple question. What does this head link give? Head link gives the address 2000, isn't that so? Because head is the pointer which is pointing to the first node of the list, and by using this pointer I can access the link part of it. That is why I will get this address 2000. Now my second question. What does head link give? What is this? We haven't seen this before. What does this head link give? For this you need to understand the meaning behind this. First of all, what does head link give? Head link gives the address 2000. Because when I simply write head, it means that I'm trying to access the content of this head, that is 1000. So I can replace this head by 1000. 1000 arrow operator link means we are trying to get to that address 1000 and we are accessing the link part of the node within that address. This is the meaning of head arrow operator link. So head arrow operator link gives the address 2000. I can replace this head arrow operator link by 2000, and then you can easily answer what does this head link give? As I can replace this head link by 2000, so I can say 2000 arrow operator link means I'm going to the 2000 address and accessing the link part of it. Isn't that interesting? So basically using the head pointer, you are accessing the link part of the second node of the list. Wow, this is amazing. I'm not even moving my head pointer. I'm not even using any other pointer, but still I would be able to access the link part of the second node of the list. So head link gives the address 3000. Similarly, head link gives null. That is, we are accessing the link part of the third node. So with the help of head pointer, we can access the complete list. So if this part is clear to you, then there is no problem in understanding method number 2. Now let's discuss method 2. Now here is this code which is using method number 2. Here we are using obviously two pointers. One is head and the current. Head pointer is pointing to the first node of the list. Current pointer is pointing to the second node of the list up to this point. Now here I am reusing the current pointer. I am allocating memory for the third node and I am putting the address within this current pointer. And here I am updating the data part as well as the link part of the third node of the list using current pointer. This is simple, right? We can do this. We can reuse this pointer because we have already seen that with the help of head pointer, we can reach any node of the list. So there is no problem in reusing this current pointer. That is why we can reuse it over here. Now you can see that here this current pointer is pointing to the third node of the list. It contains the address 3000, and obviously current is now pointing to the third node, so definitely it is not pointing to the second node of the list. And you can see there is no link between second node and third node, because here I have just allocated the memory for the third node and I'm just updating the data part as well as the link part of this node, and I'm doing nothing else. Now the next job is to update the link part of the second node of the list. In order to update this part, we just need to add this line: head link link equals to current. Now understand this carefully. Head link gives the address 2000. Now if I use head link link, it will give me the link part of the second node. So I can access the link part of the second node using this head pointer. Now I just update this link part of the second node using this current pointer. I will simply assign current to it. So it will get updated by 3000 address. Now this link part contains the address 3000, and now this node is pointing to the third node of the list. So I am just using these two pointers, head and current. Current is obviously required, but there is no need to create current 2, current 3 and so on. By using this method, we can create our single link list very easily. So this is our final code, which is capable of creating a single linked list containing 3 nodes, and that too without using extra pointers. Congratulations everyone! You have created your first single linked list. Many congratulations to all of you. Okay friends, this is it for now. Thank you for watching this presentation.